Myself, Girish Kumar, working as an assistant professor from Department of Electronics and Telecommunication Engineering, Bangalore Institute of Technology, located in VV KR Road, Bangalore 4. So this video has been recorded to teach the third sem engineering students of electronics and communication and also electronics and telecommunication engineering, where they have a subject called network theory in their third semester curriculum. I hope further my videos and my lectures will help you people in understanding the subject network theory in much detailed and with a very good explained explanation that will be given by me, and I will also be solving much more problems that you don't find in textbooks. So I'll be solving more and more problems on each techniques that you come across in every module of this particular subject. I hope my video, when you're watching, you will enjoy. Meanwhile, you will also learn subject in more detailed manner, and definitely the exams that you face finally will be much easier for you to face. So we'll all meet in the next video, which begins with the syllabus that we have in that has been prescribed by Vishweshwaraya Technological University. Okay, so all the best for all the students in learning this subject, and I hope I'll be helpful for you people to learn the subject in much detail. So you can watch my videos in a YouTube channel. You can search by giving my name, Girish Kumar NG. So you can search YouTube channel by mentioning my name, so that you will be able to watch all my videos which I'll be recording for different subjects. So please do watch, please do like, and please do subscribe for my YouTube channel. I thank you once again, and I wish you all again a very good luck for your further studies. Thank you. Today I'll be teaching you the concepts related to network analysis, which is electronic circuits network analysis. So first of all, we'll learn some of the basic concepts that are related to understand the circuit theory, and then how to solve the circuit to find out some of the important attributes in the electronic circuits, which is finding out the current and voltage values. Okay. Meanwhile, we should also think on reducing the complexity of the circuit to find out all these parameters manually. Okay. So we do have some of the softwares where you can also implement all these circuits, which is PSpice software is one of the tool which we can use it to solve this particular electronic circuits that we do it we do manual calculation to solve it. Okay, so later on, after learning manual calculations and all, I'll be also guiding you people how to use this PSpice tool to solve the same network which we are actually that we are going to solve it manually on a sheet of paper. Okay. So first of all, what are the basic concepts that we have in network theory? So that is what we will be covering in module 1 as per your syllabus copy. So module 1 is something related to the basic concepts that we need to learn. So we will be learning some of the basic concepts that are related to solve the network, electrical network that we have, and how to reduce the size of the network so that the electrical parameters like voltage, current, power, and so on can be calculated easily. Okay. So first, basic concept, the first concept that we are going to learn is we'll be learning something related to the practical sources. Means will be knowing what are the different elements that are actually used in an electrical network. Okay, as you all know that we do have two types of network. One is the DC network and the other one is the AC network. Okay, so we will be working on both DC and AC electrical networks, and we'll be seeing what are the practical sources. I hope you all might have learnt in basic electronics in your first year, where the sources that we have in an electrical network would probably be voltage source and current source. And the elements, normally we call it as a passive elements, which we normally have, you all know that I feel, which is resistor, capacitor and inductor. Okay, so we'll be learning some basic details about all these things, and then we'll see some of the basic concepts that are being used to solve some simple electrical networks. The first thing is source transformation is one of the technique where we normally use it to reduce the network into a simple format and then find out the solution that has been asked in the question. Like in question, they might ask you to find out the voltage, or they might ask you to find out the current, or they might ask you to find out the power, and so on. So to find out those parameters, we will be given electrical network where you need to apply the source transformation method, and then you need to find it out. So we'll be solving many problems related to this particular concept. So later stage we'll see that. Now the third concept what we'll be learning here is we do have something called star delta and delta to star. Both conversions will be same. So we do have one of the derivation related to the star delta and delta to star conversion, and then we'll see how to apply that particular derivation in solving the solution for the given problem. Okay, so the very important in module 1 where you can see definite once question of 10 marks that can come in your module 1 is one thing is this star delta and delta to star conversion, and one question out of I think somewhere around 6 to 8 marks you get in source transformation, and definitely one 10-mark question you will get in mesh analysis or loop analysis, what we call. Okay, so we do use this mesh analysis or loop analysis to find out the mesh currents, okay, or the loop currents, what we call. We will find out those currents, and then we find out voltage or power, whatever been asked in the question. So we do analyze this mesh analysis or loop analysis for both two types of networks that we come across in electrical networks, which is DC and AC networks. The last part of module 1 which we are going to cover is node analysis. Okay, so node analysis or node voltage analysis is what we call it as. So we do use this node analysis to find out DC and AC parameters like current, voltage and power for any given electrical network. Okay, so I hope this mesh analysis and node voltage analysis, when you come across, you people should remember some of the different laws that we have in electrical network. So let us go in detail about those laws. I hope this is the the brief syllabus that you have in module 1, and you get 20 marks out of this particular syllabus in your examination. Okay, so let us go into the practical sources that we have. So before that, as I said you, let us cover some of the basic laws that we have in electrical network or electrical circuit theory. So the first main law, I hope you people even learnt in your physics in your in your 12th or 11th, and I hope you people have learned this law even in your basic electronics in the first year of your engineering, which is very important. Though it is very simple, but this law is which is very important and which is used in our further any sort of algorithms or any sort of the solutions that we find out for any given electrical network. So Ohm's law is which is very important. Then we have Kirchhoff voltage law and then Kirchhoff current law. So these three laws what we have, which are basic laws in electrical network, is very important. Further in many problems while solving or reducing the electrical network, we normally use these main three laws. Okay, so first thing, let us go with Ohm's law. So what is exactly Ohm's law? Ohm's law is nothing but V equals I into Z, right? So Z comes in AC network, which is an impedance. Now, if your network is purely resistive circuit, then we normally write it as V equals I into R. Okay, so purely resistive means the phase angle or phase shift would be equal to 0. Okay, so all these details I'll keep on explaining you further in detail so that you will understand it much better. Okay, so Ohm's law says that V equals IR, or we can say resistor R equals V by I, or we can say I equals V by R. So we can derive all three different formulas by using Ohm's law. Okay, so normally Ohm's law we use it for to find out either voltage or current or resistance. Okay, so for example, if this is the block what we have, block diagram. Now if this A is one of the input at the one terminal, and B is the another input at the other terminal of the resistance. So if current I is passing through the resistance, then by using Ohm's law we say that voltage across this resistance would be equal to current multiplied by the resistance value. So this is what Ohm's law states. Okay. Now coming to the Kirchhoff voltage law. So what does Kirchhoff voltage law says? So the algebraic sum of the voltage drops across the loop would be equal to 0. So we can also say that, or the total voltage V would be equal to algebraic sum of the voltage drop across each impedance or resistance. Okay, so we can say the total voltage is equal to the algebraic sum of voltage drop across each impedance or resistance. Okay, so what would be the voltage drop across every impedance that we have? Now, if I say the voltage drop across this Z1, so you can say that I2 is what the current passing through Z1. So I'll say I2 into Z1 is the voltage drop across this particular impedance. Similarly, if I say what is the voltage drop across this impedance Z2, then I'll see the current passing through Z2 is I3. Therefore, the voltage drop across the impedance Z2 would be I3 into Z2. So similarly, you can also write for Z3 and Z4, wherever you can see the current passing through those impedance and multiply current with impedance, then that gives you the voltage drop across that particular component. I hope you got it. Kirchhoff voltage law is what normally used in series network. Okay, now you can see these four impedance are actually in series. These four impedance are actually in series. I hope if you remember, in a series network, voltage divides, right? Voltage divides in a series network. So when voltage divides in a series network, what would be the voltage, total voltage across those series network? So that divided voltage, if you sum up all those divided voltage, then that gives you the total voltage applied to that particular circuit, right? So in series network, I am saying you again, in series network, voltage gets divided. Okay, so that is what the significance of Kirchhoff voltage law says for anyone when they are analyzing any problem using KVL. So in short, we call it as KVL. Okay, KVL means Kirchhoff voltage law. Similarly, when I go to Kirchhoff current law, okay, Kirchhoff current law, what is Kirchhoff actually? It is a scientist name who actually given these two law. Okay, so he gave voltage law and current law. Now, what is current law? So the current law says the algebraic sum of current entering into the node is equal to the algebraic sum of current leaving the node, okay, or leaving the branch, anything you can say. Okay, so here I1, I2, I3 are entering this to this particular node, whereas branch I6, I5 and I4 are leaving this particular node. So therefore, all entering you sum up and all leaving you sum up. So entering, summed value of this entering will be equal to summed value of this leaving. So therefore, I1 plus I2 plus I3 will be equal to I4 plus I5 plus I6. So this is what Kirchhoff current law, in short they call it as KCL. So KCL in the sense Kirchhoff current law. Okay, so Ohm's law, Kirchhoff voltage law and Kirchhoff current law is what which is very important for you people to keep in mind. For any electrical network, we normally use these three laws to solve it or to find out the voltage, current and resistance values. or impedance values in an AC network. Okay, now the next thing is you need to know when currents get divided and when voltage gets divided. Okay, as you see here, current division circuit here, this is the currents, this is an example of current division circuit. You will get plenty of this, but different types of networks, what you can see like this. So this is purely resistive network because we don't have an impedance. When do we see impedance comes into picture? When there is a capacitor and inductor in the particular circuit. Okay, so if you have only resistance, no impedance, there is only resistance. But when do we say that there is an impedance in the circuit? When we have a circuit which is connected with capacitors and inductors. Okay, so therefore here it is a purely resistive network. Now I1 is the total current passing through the network, or I1 is the response that we get because of the excitation, which is voltage V. Now that I1 gets divided into two different currents, which is I2 and I3. Now as R3 and R4 are in series, therefore same current flows through R3 and R4. I'll repeat, as R3 and R4 are in series, therefore same current flows through R3 and R4. Okay, so I1 is flowing through R1, gets divided into I2 and I3, and then as R4 and R3 are in series, so the same current I3 flows through R4. So this is how the current gets divided. Why? Because R2 and R3 is quite parallel. Okay, R2 is parallel with R3 and R4. Therefore, the total current I1 gets divided in the parallel circuit. Okay, in a series network, voltage gets divided, whereas in parallel network, current gets divided. Keep this in mind. Okay, in a parallel network, current gets divided. So in a voltage division circuit, as I said we do have a series circuit here where R1, R2, R3, R4 all are connected in series, and total voltage is V. V1 is voltage drop across R1, V2 is voltage drop across R2, V3 is across R3, and V4 is across R4. Then we do have the total voltage V, which is equal to V1, V2, V3, V4 all added up. So V1 plus V2 plus V3 plus V4, and that would be the total voltage here. Anyhow, this voltage division circuit says that the voltage is getting divided across each resistors which are connected in series. Okay. Very important in an electrical network, which we normally see, is called as redundancy conditions. Okay, so it's sometimes the examiners make the questions to be very complicated, but if you try to analyze that particular question and if you try to see what exactly this question or this network has, you will see most of the things are redundant in nature. So if you remove those redundant conditions in your electrical network becomes very simple, and finding out the solution for simplified network is very easy. Okay, so it's all the technique used by the examiner to confuse the student. So what exactly the redundant condition that you can find out in any electrical network? So what would be the redundant conditions that you come across? The first redundant condition is, if you find out any resistance in series with the current source I, if you find out any resistance R in series with the current source I, then this is a redundant condition, because though the resistance is connected in series with the current source, but the current remains constant when it passes through that resistor. Irrespective value of the R, the current remains same in series. Okay, irrespective value of the R, the current flowing in a series network will always remain same. So whenever you find out a resistance of any value which is in series with the current source, you are going to remove that resistance and you are going to short it. Okay, you are going to remove that resistance and then you are going to short it. That is what we do to simplify the electrical network in more simplest way. Okay, the second redundant condition is, we do have voltage source when you find out in parallel with the resistance. See, the voltage drop across the resistance in a parallel network remains same. Okay, in a parallel network, the voltage drop across the resistance R remains same, irrespective value of the resistance connected in parallel, but the voltage across those parallel network remains same. Okay, so what we do here is, as voltage doesn't drop in a parallel network. So what we do here is we normally remove the resistance and we create an open circuit there. Okay, because voltage is not getting dropped irrespective value of the resistance. So I am going to remove R and I am going to make it open. Okay, so when I say open, very important point which I am saying you, if you want you can rewind my video and listen to this. When R equals 0, it means short. It means when resistance value is 0, it means that that circuit with R equals 0 becomes short. When resistance value is infinity, means if the resistance value is very high, then that particular circuit will behave as an open circuit. Okay, so that is what here R open means R is infinite, here short means R is 0. Okay, similarly when current equals 0 and when current is infinite. Okay, when current equals 0, it means that it is open. Okay, so how to go away with short circuit, or how to make the circuit to get away from short circuit, which creates a shock for human. So you make current 0. Okay, so when I make current 0 in that particular network, then that particular network becomes open. Then you see that no current passes through that network. Okay, similarly when the current is infinity, when the current becomes infinity, then the particular current source will behave as a short circuit. Okay, then definitely when current equals infinity and if it's short, then an infinite current will be flowing through that loop, and you should be very careful. Those components which are connected in that loop will get damaged. Okay, so therefore when I equals infinity, it behaves as short. When current I equals 0, it behaves as open. Whereas voltage, when V equals 0, it behaves as short. When V equals infinity, it behaves as open. So when you make voltage to be equal to 0, it means that that particular circuit is becoming short. And when you are making voltage to be equal to infinity, it means that that particular circuit is becoming open. Okay, so these three terms is very important. I'll just repeat again. R equals 0, short. R equals infinity, open. I equals 0, short. I equals infinity, open. I equals 0, which is open. I equals infinity, which is short. V equals 0, it is short. V equals infinity, it is open. Okay, so please learn these three terms, and if you know all these three terms, then definitely learning the concept in the electrical network becomes much simpler further. Okay, now we will get into the practical sources that are available in the electrical network. Okay, so first thing is we'll see this particular flow diagram. Okay, so electrical elements are of two types. We have two types of elements in an electrical network. One is the sources, the other one is passive elements. Now what are the sources that are available in the electrical element? One is independent sources and the second one is dependent sources. Okay, independent sources means it is not dependent on any other parameter. Dependent sources means such sources are dependent on other voltage or current. Okay, so we'll see an example for that. Okay, so here passive elements is what the second elements in an electrical network, family of elements that we have in an electrical network. So the passive elements are the resistor and inductor and then capacitor. Okay, so resistor, inductor and capacitor. So three different passive elements that we have. Now what is that passive elements do? Resistor will consume energy, so it is called as energy consuming element. Whereas inductor, it stores energy in a magnetic field, and similarly capacitor, it stores energy in an electric field. Okay, so these two are storing devices which we normally use it for. Whereas resistor, it doesn't store anything, it just consumes energy, means it just delivers the energy in terms of heat. Okay, that is what it does. Okay, coming to the independent source. So we do have two types of independent sources. One is the voltage source and the other one is the current source. Okay, so normally we assume the sources to be idle. So when I say idle, okay, when I say voltage source is idle, for an idle voltage source, I'll say internal impedance is 0. Okay, for an idle voltage source, the internal impedance is 0. Very, very important term which you need to learn. When I say the source is idle, it means that its internal impedance is 0. So it behaves, that impedance behaves as short when it is 0. Similarly, for an idle current source, when I have a current source when it is idle, for such source, the internal impedance is infinity. So infinity means it behaves as open. Okay, for an voltage source it behaves as short, whereas for current source it behaves as open. Keep this in mind when the sources are idle. Now if those sources are not idle, then definitely for voltage source there will be some sort of internal impedance, and for current source the internal impedance, minimum internal impedance will be there. Okay, because for idle internal impedance is too high. So for a practical current source, then definitely internal impedance will be very low. Means very low internal impedance will be there for practical current source, whereas very bit more of internal impedance will be there for a practical voltage source. Now if in the question, if they don't give you whether it is practical or idle, your job is to assume that voltage source and current source is idle. Means you are assuming that voltage source has internal impedance which is 0 and current source has an internal impedance which is infinity. Okay, so you should assume, if it is not mentioned in the question, you should assume it as infinity. Now coming to next part, the symbol. For a voltage source, this is the symbol which is used. Okay, for voltage source, this is the symbol, a circle with plus and minus polarity for the voltage source. Similarly, the current source, you can see this is the current source which is being used. So current source with an arrow, upper arrow mark says the positive polarity. Okay, so this upper arrow says this is plus and this is minus. Okay, you should be very careful. When you see arrow, it is a current source. When you see plus and minus polarity, it is a voltage source. Very important. Now coming to dependent sources, as I said, dependent sources will be dependent on something. Okay, so here rhombus is the symbol which is used for dependent source. Circle is used for voltage source. Circle is used for the independent sources, whereas rhombus is used for dependent sources. Keep this in mind. Circle is used for independent sources, and whereas rhombus is used for dependent sources. Got it? Now we do have 4 types of dependent sources here. So as I said, when you have an arrow, it is a current source, and when you have plus and minus inside the rhombus, then it is a voltage source. You should differentiate like this. When you have an arrow, it is a current source. When you have plus and minus polarity mentioned inside the rhombus, then it is a voltage source. Understood? Now you should see the parameter which is written with respect to that particular symbol. You see A into I. First of all, this is a current source, and then you see A into I means this is a current value. Therefore, this is current dependent current source. I hope you got it, right? I means current, right? So current dependent current source is what this. So similarly, you have plus and minus, means it is voltage source, first thing, and you see current value here. So therefore, this is current dependent voltage source. Understood? Current dependent voltage source. Similarly, we do have next symbol here, which is an arrow. Arrow means it is a current source, but see the value here, it is voltage. So therefore it is voltage dependent current source. Okay, voltage dependent current source. And then at last you have again plus and minus, so it is a voltage source. Plus and minus means it is a voltage source. But you see what is the value here? It is V. It means that again it is voltage. Therefore, it is voltage dependent voltage source. So this is how you try to find out the different types of sources when the symbol is mentioned in the network. Okay, when symbol is mentioned in the network. Now here, recall again, there are 4 types of dependent sources. One is current dependent current source, current dependent voltage source, voltage dependent current source, and then voltage dependent voltage source. So these are the 4 types of dependent sources that we have in electrical network. Okay, so this is all about practical sources, which is the first topic in your module 1. Now coming to a small example circuit that we have, a small example, don't go with the circuit complexity, or if you think the circuit is too huge or something. So we are not solving this network at present time. We'll see later how to solve such big networks in a very simplest manner. But my job is here to tell you what is practical sources and what is dependent sources in the given network. Okay, so that is the only job which we do. Now coming to this source in the network. So coming to this source in the network, what is this? Arrow mark is there. So is it a current source? Yes, fine. Now what is this value is? It is a voltage V. So what is this? Voltage dependent current source is connected in parallel with this 3 element. Okay. Now my job is to find out where is this V1. Where exactly this V1 is in the network. So V1 is the voltage drop across this inductor L1. Understood? So you find out this V1 in this particular branch, and then you put that V1 here and find out the exact current source value. So this is how dependent is all about. So it is dependent on V1. This current source is dependent on V1. Now where exactly V1? So V1 is here, the voltage across L1. Therefore you try to find out voltage across L1 and then substitute that value here. Then you find out the exact value of this current source, which is being dependent on V1. Understood? See, in any network, if they give a dependent source, and if that source is dependent on some parameter, then that particular parameter should be mentioned elsewhere in the circuit. If that dependent parameter is not mentioned elsewhere in any part of the circuit, then definitely you can't solve it. That is an error in the question, let me say that. Okay, they should give the dependent parameter should be mentioned somewhere else, elsewhere in the part of the circuit. Okay, so similarly the next thing is K into I1. See, K into I1 is the source. Now how do you find out what type of source? I said inside arrow or inside plus or minus. No bother if it is also mentioned outside. See here, minus and plus, it means that it is a voltage source. Okay, outside it is mentioned, so it doesn't bother whether it is inside or outside, but this is a voltage source. They should definitely mention either arrow or minus plus, either outside or inside. Okay, so therefore as it is a voltage source, this voltage source is actually dependent on the parameter I1. Right, I1 is what? I is used for current. Therefore I1 is current, therefore this is current dependent voltage source. Understood? Now where is exactly this current I1 is? Can you see here? See, this is the I1, which is the current through this particular complete branch. Okay, current passing through the series network R2 and L2. So find out the current through this particular series network, substitute that I1 here and multiply it by K, and that gives the exact value of this particular dependent source. Okay, and this source is controlled by I1, whereas this source is controlled by V1, which is voltage across L1. So I hope now you got the brief picture on the dependent sources. Now let me come back to the practical sources here. Now how do I say this combination of V and R1 is a practical voltage source? When you find out a resistance in series with V, okay, when you find out any resistance in series with the voltage source, then such type of network can be called as practical voltage source. Okay, such type of network can be called as practical voltage source. It means that this voltage source V has an internal impedance R1. Okay, this voltage source V has some internal impedance of value R1, and anyway R1 what value we haven't given. So as I said you, for a practical voltage source, if the internal impedance is 0, then it is called as ideal source, right? So therefore there should be some value of R1 here. Okay, so this is the practical source. So combination of R1 and this V is what practical voltage source is called as. I hope you understood. Now coming to practical current source is what the combination of this I in parallel with this particular network. Okay, this is what practical current source. Why practical current source? Always when there is a current source in parallel with any series combination of resistance and inductance or anything, okay, when you find out any branch in series with I, and if that particular branch has some internal impedance or some low internal impedance, then definitely that particular current source becomes practical current source. Okay, that becomes a practical current source. Okay, I hope you people got this particular concept of practical voltage source and practical current source. And if at all it is not called as practical sources, and if in question if they give you it is an idle source, then don't consider this R1 with V. Assume that V has an internal impedance to be equal to 0, and assume that the internal impedance of the current source is infinity. That's it. Okay. So you just need to assume that the voltage and current source are idle and all other components are a part of the network. Now if they give you practical, then you should assume that R1 is an internal impedance of V, whereas R2 in series with L2 is an internal impedance for I. Understood? Concept is clear? Fine. Can we go to the next concept then? Fantastic. Okay. I hope you people are understanding my videos. Anyway, now let us go with the types of network that we have in electrical circuits. Okay. So we normally see three families of networks. One is linear and non-linear networks, passive and active networks, unilateral and bilateral networks is what we see. Normally we go with linear, we go with passive, and we also go with some sort of bilateral and unilateral. We'll see. Okay, why we don't go with non-linear or active networks? Because linear networks or passive networks normally works with the passive elements resistor, inductor, and capacitor, whereas non-linear networks or active networks normally go with the semiconductor devices. So therefore, semiconductor devices we are not going to cover in electrical network theory. You will be learning on semiconductor devices in one of the subject called electromagnetic devices, or you will also learn semiconductor devices in analog electronic circuits subject. So I will not be covering non-linear networks or active networks in this particular theory. Because our concept is very clear here, is we are learning different concepts or different techniques that are used to solve an electrical network. That is what this particular subject is related to. Okay, so non-linear comes into picture when you see the response for a given excitation is not constant. It gives a different response for the different excitation. That is what non-linear is all about. Okay, so let us see the definition only. So if E1 and E2 are two different excitations here, and R1 and R2 are response, and if E1 of t plus E2 of t is excitation, then the response will also go with this, which is R1 of t plus R2 of t, and such network is normally called as linear network. Okay, so non-linear will have semiconductor devices which doesn't give a constant, means which is not related with the excitation, it gives a different responses. Okay, so you all know about semiconductor devices, transistors, diodes, capacitor with PN junction and so on. So those things comes under non-linear, or those things comes under semiconductor devices. Okay. Coming to passive and active networks. So passive is normally energy delivered to the network is always positive. Okay, passive will always energy delivered to the network is always positive, where no voltage and current appears between any two terminals before any excitation is applied. So before applying any excitation, there will not be any response until and unless the excitation is applied. But active elements is not that case. You will have an initial behavior for the active elements. Normally, you will have some sort of behavior or some sort of current, even though the excitation is not applied. Okay, so that is what, which is normally the generators or amplifiers or oscillators and so on. Okay, so normally all these generators or amplifiers or oscillators are been designed or are been modeled using transistors. Okay, so you will learn how to design oscillator or amplifier or how to design a generator in your analog electronic circuit subjects. Definitely or solid state devices or something like that. You have different subjects there. So in those subjects you will learn how to design oscillators or amplifiers. That is what active network is all about. Okay. Now coming to unilateral and bilateral. Okay, so here we normally go with bilateral network. We don't go with unilateral network because bilateral is the one which contains RLC network, and we don't go with semiconductor devices. So unilateral is omitted here. So we go with bilateral only. So the circuit in which voltage current relationship remains unaltered with the reversal of polarities of the source is said to be bilateral. So what you do, you keep a voltage or current source in your particular circuit, and then you reverse the polarities of that, so the response remains constant. That is what it means. So the only thing is the polarity is altered. Okay. So for example, you go clockwise or you go anti-clockwise. So if the answer is 3, and if you go with the anti-clockwise, the answer will be -3. So we are not bothered about the response. We are bothered about the value. So 3 is the value which we get. So you go clockwise, you get 3. Whereas you go in anti-clockwise, you should get 3 again, but with the polarity -3. Okay, so that is what. That such type of network is called as bilateral network. Whereas unilateral relationship are different. Reversible of polarities of the source, the circuit is said to be unilateral. Okay. Now when you have a biasing circuits using transistors in future, I hope for your level of knowledge, I should not speak about biasing elements and all. But if you have learned in basic electronics, I hope you all know what happens if we change the polarity of the diode, right? Reverse bias or forward biased. I hope you all know about that. So if the polarity of the diode is being exchanged or altered, or the diode is reversed or kept as it is, the response is different. Okay, so if it is reversed, it becomes reverse biased, and if it is straight, means it depends on anode and cathode terminals also again. So I hope if you remember forward bias or reverse bias, so that is where the unilateral circuits will not show the same response when the polarity is been exchanged. Okay, so that is what unilateral we are not going to use here, because we don't have anything to work on diode or transistors in this subject. So we'll not bother about those particular networks. Okay, so we'll be working on bilateral network, we'll be working on passive networks, and we will be working on linear networks. So non-linear networks, active networks, and unilateral networks will come in analog electronic circuit, but not in network analysis. Okay, I hope this session till now, whatever I have covered, you people are much you people have got the very good knowledge on what is the different types of basic electrical laws that we have. First of all, I am sorry, I think you got the knowledge on what concepts you people are going to learn in module 1, and then coming to the in detail about the module 1, we learned what are the different laws: Ohm's law, Kirchhoff current law, and Kirchhoff voltage law. And then what we have learned is the current division circuit or voltage division circuit, and then we saw what is the redundancy condition that we come across in an electrical network. And then we came across with different types of electrical elements. There we have seen we have independent sources and dependent sources, and again in independent sources we have seen we have ideal sources and practical sources, where we have seen in an ideal sources, for an voltage ideal sources, the internal impedance will be 0, whereas for an ideal current source the internal impedance will be infinity. And then we have seen dependent sources. We have 4 different types of dependent sources: current controlled current source, voltage controlled voltage current source, and then current controlled voltage source and voltage controlled voltage source. We have seen all 4 types. And then we have seen passive elements in an electrical network, which is normally energy consuming, which is the resistor, and storing energy in a magnetic field is what inductor, and energy storing in an electric field is what capacitor, which are the passive elements that we have. And then we have seen a small example of a circuit where we have seen how to find out the dependent sources and how to find out these practical sources and all. Okay, and we have also seen some sort of passive elements in the particular network. And then finally we came across with the types of networks that we have in electrical networks. So we have learned about linear and non-linear, we have learned about passive and active, and we have learned about unilateral and bilateral. And later we decided that we are going to use linear, we are be working on passive, and we will be working on bilateral networks. And non-linear, active, and unilateral is all related to semiconductor devices. So in this particular subject we don't use any transistors or diodes, so we don't cover that particular topic in this particular subject. So we'll work only on these passive elements, RLC circuits. Okay, fine. In my next video you will see the next part of the module, which is source transformation. Thank you.